Now we know some transformations. Let's talk about how we're going to graph exponential functions. We just learned our exponential functions equation. Okay, one of our standard equations here. All right. Key features we have to look out for is our base. And what we want to look for is if my base is greater than 1, what does that have to be? I hope you did answer out loud and say growth. And if my base is smaller than 1, we want to recognize that we should have a decay. The other special feature is our asymptote. And that's a y value at y equals k. When we come across graphing problems, the first thing we're going to do is we're going to determine if we have a growth, I'm going to abbreviate that with a G, or a decay. I'm going to abbreviate that with a D. Do we have a growth or a decay? Remember, that's based off of B. That's going to help us determine the shape of our graph. Then we want to determine our asymptote. We're going to state the asymptote as y equals k. That should just be the k value that I see at the very end of my function. Once we know it, we're going to graph the asymptote with a dotted line. Now, we use a dotted line because your asymptote is this imaginary line that your graph can never, ever, ever, ever cross. So we want to be sure to put that this is the absolute bottom of my graph. We cannot go any further. Once we have done that, very similar to quadratics, we're going to state our h value. We're going to make sure we change the sign. And we're going to put it in the middle of our table. Once we have done that, again, so similar to quadratics, you're going to pick 2 points above h and 2 points below h. Scroll that up for you. Okay. Once we have our table filled in, okay, we're going to complete our table and graph. Complete your table and graph. So let's look at our example down here at the bottom. Okay. The first thing we have to do is, do we have a growth or a decay? Remember, that comes from your parent function here. Okay. My parent function has a base of 2. Is 2 bigger than 1? Yes. So we have a growth. Now I'm going to determine my asymptote. My asymptote is in the k value. All right, so this is my asymptote. And it's at y equals a -3. So after immediately identifying it, we're going to go on our graph to where y equals a -3. And put in our imaginary dotted line. Now I need to identify the h value. Here's my h. Okay, I'll make a table really quick. That h value is going to be a negative 1. I'll write h equals right there. It was positive in my equation. We have to remember to do the opposite as h equals negative 1. I'm going to pick 2 points that come before it and 2 points that come after it. Just like in quadratics, we got to make a table in our calculator. So if you have a graphing calculator, go ahead and take that out. My batteries are low. We have to go to y equals just like we did before. I'm going to clear out what I have written. We need to write exactly what we see in our equation here. So I'm going to write 2 raised. And if you have a floating box, you're in good shape. You can just type in x plus 1. If you did not get the floating box, please be sure to put this exponent inside parentheses. Now, arrow to the right and subtract 3. Now remember, we went to the table button here, so we're going to hit second table. And I'm going to search for my values here. So I'm going to plug in, let's start at the bottom, 1, 1, 0, negative 1, negative 1, negative 2, negative 2.5, and negative 2.75. Now, if you have a TI-36, your process is going to be the same. You're going to go to your table button. You're going to scroll down to edit function. Your X button. I'm sorry, we got to put in that 2. 2. Here is your exponent button. It's the X box button. So go ahead and click that. So we can type in x plus 1. You too will have to arrow to the right and subtract 3. Remember, your start is where your table starts. It starts at a negative 3 and it counts by 1s. Now your calculator is giving you the fraction version of what I have here for decimals, and that is totally fine. So now it's time to graph. Let's start with the points that are actually whole numbers. We'll start at 1, 1. We'll start at 0, negative 1, and negative 1, negative 2. Now, these decimals are going to be very hard to graph. So I'm going to encourage you to not stress over that because they will be taken care of. When we graph this curve, we're going to get super, super close to that asymptote, and then we're going to connect our points. By getting super close to the asymptote, we're kind of accounting for that negative 2.5 right there. That negative 3, 2.75 is a little bit lower. Okay? So we're just going to get really close to account for these decimals and connect my points into a curve. I encourage you to try some practice problems at home, but we will practice in class tomorrow as well. Again, please come prepared with some questions.